Okay, so we are going to do just a quick little video about reducing, or simplifying, should I say, simplifying radicals, and specifically in this situation, square roots. So the big thing that we're going to be looking at are for perfect squares. So in order to simplify a square root, you have to be able to break this number into factors, two numbers or more that multiply together to equal it, where one of the factors is a perfect square. So perfect square is the number that you get after squaring any standard number. And so here I have the classic, at least 2 through 12 numbers squared. And so that thus creates and gives us our perfect squares over here. So if any of these numbers is a factor of the number that's underneath our square root sign, then we can simplify it and basically square root it out and bring that out of the square root. So let's look at this. And this is kind of a little bit of guess and check is one way. There's other ways shown on the internet in terms of breaking it into smaller factors and smaller factors. But this is one way that I like to do it. And so we have 108. So obviously any number that I have doesn't go into 108 evenly, not by itself. So the next question comes is, okay, so is any one of these numbers a factor of it? And we want to get the largest factor. And what that means is we want to make sure that whichever one happens to go into it gives us our remaining number in and of itself also does not have a hidden factor that's a perfect square. So let's see what this looks like. So let's kind of like start with 4. So the question is, what is 108 divided by 4? So if you were to divide this by 4, make sure I'm on my right layer here. If you were to divide this by 4, then you get 27. But the problem with that one is 27 can still be simplified to a perfect square that has a 9. So if this is simplified with a perfect square, then that's not the greatest one that can go into it. And again, this is kind of a guess and check, but if you learn how to do this fast enough, it can go by, well, just that, pretty fast. So what about 9? Can 9 go into 108? So 108 divided by 9. So if you were to say 9, you get 9 times 12. But 12 can actually still be reduced in 4 times 3. So again, we have it where, nope, that can not as simplified as it could be. That's not my largest number that can go into it. And this is a nice kind of, doesn't matter as long as you have these numbers, you can work through it process. Okay, so what about 108 divided by 16? If I do 108 divided by 16, what I actually get is a decimal. It's 16 times 6 and 75 hundredths. That is not what we want. We don't want to deal with the decimal. So that even rules out that 16 is not a factor, a true factor of that in terms of at least working with our whole numbers. So we're not going to even worry about 16. Okay. So what about 25? Well, the only thing about 5s is that it ends with an 8. So that means any number that ends with 5 can't go into it. So I'm not even going to bother with 5. So what about 36? Divided by 36. And when I divide it by 36, which is a perfect square, I get 3. Well, 3, I can't reduce that any further. There's no perfect squares that go into 3. So I have my answer. I can rewrite 108 as the factors of 36 times 3. And so when I go and start simplifying this and take the root of each one of these factors, then I can come back over here and go, well, the square root of 36 is 6. So I can simplify this down to 6 times the square root of 3. So this is one way that you can go about to simplifying it. So let's see another example. Okay. So I have 200. Now, one thing you can sit there, and again, if you're familiar with your factors, and say what numbers, when multiplied together, give you 200, and what number over here in my perfect squares is the largest number that could go into 200. So hopefully, instead of going 200 divided by 4, divided by 9, divided by 16, divided by you can go, well, factors of 200 is 100 times 2. And 2 can't be simplified any further. 100 is a perfect square, so boom. I can then break this into 100 times the square root of 2. I can simplify that, and I get 10 square root 2. So you don't always have to start here and work your way up. You can go, well, what about this number? What about that number? What do I know? Again, the last one, I said, well, 5 can't be a factor of it because it ends with 8. So you can start using some of that number sense to eliminate choices and solve them and simplify them a lot faster. Right? So here we have this one. We have 32. So again with this, if I start 4, chances are 4 might go into this, but it's going to be not the largest value that can go into it. So you sometimes can kind of jump and say like, well, what about something in the middle here? Maybe we'll try 25. It does end with a 0. So the question is this number divisible by 25? Like, well, wait a minute here. 5 does go anything with zeros, but 25 wouldn't go into 320, or at least anything go into 325. So not that one. So let's try let's try 16, because that would be too high. So I'm going to do 32 divided by 16 and see what I get, or 320. And I get 20. But the question is, can I still factor and simplify with 20? Yes, I can. I can break it into 4 times 5. I can break it into 2 times 10. So yes, 16 goes into it, but it's not the largest number. So let's try 36. Nope, that gave me a decimal. What about 49? Nope, that gave me a decimal. What about 64? Well, when I did 64, I got 5. To the factors, 64, the square root is 8, and I am finished. So you can see how you can start kind of doing this faster as long as you know your roots. So again, so now I have 147. All right, well, the only thing I'm looking at is that if I usually multiply an even number, so I cannot ever multiply 16 by any number and get an odd number. 16 times 9, I'd still get an even number. So you can't multiply an even number and get an odd number. So that means 16, all my even numbers aren't even an option for what can go in here. So I get 9, 5 can't go into it because of the fact that it doesn't end with a 5, so that's not going to be a factor of it. And 9's on the small side considering how big this is. So these are what I'm kind of left with. So I'm going to start with 49. So 147 divided by 49, and I get 3. 7 square root 3. Done. So that's a neat thing about once you kind of start noticing the pattern of numbers and how they relate, you can start narrowing it in and go, okay, there's really not that many options sometimes when it's all said and done. And if it's divisible by 49, that means that the square root of 49 is 7, and so I can simplify it. So, and that would be true for all factors and going from there. Oops. Okay, so 80. Obviously, anything greater than 80 isn't going to be a factor of it. I can't take 64 and times it by 2. 49 times 2, okay? Because if I can't even double it, then it's not going to work as a factor of this. So 36 times 2 would be 72, which means it can't go in evenly. 25, well, 25 times 2 is 50. 25 times 3 is 75. So that's not going to go into it. So what about these numbers here? So let's try 80 divided by 16. And it goes in 5 times. Because factors, remember, mean this perfect square times some whole number should equal that number inside there. So you're welcome to pause this one, try it again. If you notice, we have an odd number here. So if this is an odd number here, what does that already do to your possible perfect squares over here that you can use? Not only is it an odd number, but it's a 7. So out of my odd numbers, which perfect square over here is also automatically eliminated? So can you find the factors? Go ahead and pause it and simplify number 6 on your own. All right, so let's try this. All even numbers are eliminated. Okay, my 5 is eliminated. 9 is probably going to be too small. So let's try 81. You can go, well, 207 divided by 81 is, again, a decimal. So what about divided by 49? Is a decimal. So 81 was a decimal. 49 was a decimal. So, oh, well, I'm going to say 121 times 2 won't work. So, well, let's try 9 and see what we get. So what is 207 divided by 9? And you get 23. So there's our factor. Square root 3, square root 23. So again, This is a way to go about to simplify radicals and to help with any of those situations. And overall, I hope this helped.